Here we go. So on the given graph, mark lengths that represent f of 2 plus h, and f of 2 plus h minus 2. Okay, so what is f of 2? Where is that? F of 2 is this length right there. That right there is f of 2. That length is f of 2. You know that. When you put in 2 into the function, it outputs that distance. That is f of 2. So 2 plus h, what are you going to have to mark off in order to get a 2 plus h? Mark off, let's say this is h right there, right? So this distance right here is 2 plus h. So what is this distance right here? That is f of 2 plus h right there. That distance is from 2 to 8. You just say it's h. There it is. And then it says, what? Then you need to mark f of 2 plus h minus 2. Where's that going to be? Well, you just go straight over it here and you cut it off. So this distance right here, that distance right there is f of 2 plus h minus f of 2. That's it. There it is. And should make h positive. They wanted h to go to the right, is all they were saying with that. What line has slope f of 2 plus h minus f of 2 over h? What line has that slope? Well, which line has that slope? You draw it, right? Where is it? Yeah, you're going from f, so that it's what has this slope. So it's going over h and it's going up what we just labeled, right? So what line has that slope? It's this line right there. That one right there.
So all we have to do is just like that.
The line. Yeah, you would say the line, you could say it like this to be super specific. The line connecting. Yeah, but you need a point. So you have to say connecting 2 comma f of 2 and what's the other point? 2 plus h comma f of 2 plus h. There it is. What line has that slope? That line has that slope right there. You're just interpreting. Put them in, arrange them in increasing order. So g of 0, first of all, so here's 0. Great. What can you tell me about g prime at negative 2? What can you tell me about this? That you definitely know it's what? No. What is g prime? It's definitely what? You know it's definitely positive, right? G prime at 0 is definitely, you know, this is negative. G prime at 2 is positive, and G prime at 4 is positive, right? So now, so you know that the negative, you know that, so you definitely know it's going to go like this. G prime of 0, you know it's going to go like that, correct? Now you need to look at the relative steepness of which 3? These 3, right? Which one looks steepest?
The G prime of negative.
This looks steepest. Which one looks the least steep? Least steep, and looks like it's y equals x, right? Kind of looks like y equals x, like 1 would be the slope on that one. So if you're going to put these in order, you now write it as, what's the least? So you put g prime of 4, and then what? G prime of 2, and then the steepest one is g prime of negative 2. Yeah, it's a visual inspection, like just steepest to less steep, that's it. Do you know this conclusively? No, but it should be clear enough. If they don't give you a function, you can't find the actual numeric value. This is literally you can put your ruler there and just estimate. It's about 2, it's about 1, right? It should be clear enough. They're never going to give you a comparison one where it's like this and this. They're not going to do that to you. You can't tell. Okay, let's move on to, I would regroup as such. I would do a plus h to the 4th minus a to the 4th minus 5a plus h plus 5a. Do you see what I just regrouped it right there? Are you okay with that? And I'm just going to work on the numerator so I won't keep on writing h. All I did was regroup it. You see what I did there? This turns into a plus h squared minus a squared times a plus h squared plus a squared, because what is the first two terms are the difference of what? A plus h plus a. Oh, it's minus. It is minus a. Good. Because you're subtracting out a negative 5. So I factored out a negative 5. So if I factor out a negative 5 from the last term, what does that a become? It becomes negative. So then I would further do it as a, ready? A plus h minus a times a plus h plus a. That's the factored form of the first term because it's the difference of squares. This one still stays the same because can you factor easily the sum of squares? No, you can't. Very good. And then this just turns into minus what? 5h, right? So the first term cancels, and you're left with h times 2a plus h times a plus h squared plus a squared minus 5h. Are we okay with that? This right here, I subtracted the a's, and it turned into h. The 2 a's right there turned into this, and this stayed the same. Is everybody still with me? You still with me? What's in all the terms now? Here's only 2 terms. There's this term and that term. What's in both terms? H. So this turns into h times 2a plus h times a plus h squared plus a squared minus what? 5. And this is all over h, and it's the limit as h approaches 0. What cancels now? The h's cancel, and you end up with h going to 0, so it turns into 2a times h squared. No, 2a times a squared plus a squared, right? Minus what? 5. The 5 stays in there, right? It's not being multiplied by anything. So you end up with 2a times 2a squared minus 5. So that turns into what? 4a to the minus what? 5, right there. So here we go. So there are 4 different ways, and hold on, I gotta pause for one thing. The notation, and yes, you can chew that and then finish eating, okay? There you go. On that note, no, you can't. Come back on time from lunch. Then you can eat. Okay, d and d over dx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. So if you're asked to differentiate something, you are being asked to calculate a derivative. This is important. The last phrase there. A function f is differentiable at a if f prime of a exists. So if it's differentiable at an x value, if you can actually find the derivative. That's one way to think about it. It is differentiable on an open interval. This is an open interval right here. This means the interval, these are x values going from infinitely close to a to infinitely close to b. This is not a point. This is interval notation. How many of you have seen interval notation before from Algebra 2? Interval notation. This means on the number line, open dot at a going to the open dot at b. That's what it means. It's not a point. This happens in math where the same thing written the same way means 2 different things. It just happens. Or lots of other types of open intervals. It is differentiable at every number in the interval. So if I said a function is differentiable on the interval from a to b, it means that you can find the derivative for any value between a and b. That's all it means. So if I said just a function is differentiable, that implies that it's differentiable at every value on its domain. So if you say a function is differentiable but an open interval, does this mean it's differentiable necessarily at a or at b? No, it just means on that particular